Hello.
Hi everybody, welcome back.
Let's go with this 2-1 thing.
Okay, so most of the lines in quadratic stuff you already know. We're going to fill in a few of the blanks.
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 We have a lot of data here, yes?
Yes, we do.
And we want a regression, yes?
Yes, we do. Linear regression.
So what do we got to do first?
We're going to have to put it into our stat button on our calculator.
I already did it.
Yay.
Aren't I special? Okay, so we press stat
We do.
and then edit, and there's our data.
Okay, so then all
Press
we have
pause
to
if
do...
you need to put it in there, or I guess some of them probably just watch it anyway.
Sometimes, yeah.
Okay.
So the key here is we want to make sure we don't have rounding errors. So
No
we're going to
rounding.
go ahead and do our linear regression,
Stat,
and we're going to stat calc,
calc.
a linear regression, option 4.
Now, I'm going to butt in here for a minute. Some of
Okay.
you have a calculator that doesn't look like that screen.
It doesn't.
It'll say lenreg at the top, and it'll say xlist, ylist, frequency, and store regression equation. If that's the case, leave xlist as L1 and
L1.
ylist as L2.
Assuming that's where you put the data.
Skip the frequency thing. But under store regression equation, we want to put y1. And you may press alpha F4 and select y1 on your calculator, or you can select y1 the same way we're going to do it here. Just, if you have any questions on that, please come talk to us. But
Yep.
we've got all kinds of different operating systems going on. So we're going to run through it with the old one, because
That's what most of us have.
there we go.
Okay, so we're going to do our linear regression on list 1, and we need a comma, and list 2. And most of us skip this part because the calculator defaults to list 1 and list 2. But if you go ahead and put it in there, now you can tell it right away where to store this regression
But
equation.
wait, there's more. Last time we did it a different way. This
We
is
did.
easier, actually.
So if we're going to go to vars now,
Bars.
and to y-vars, it's already highlighted for functions, so hit enter, and it's already highlighted for y1, so hit enter again. Okay? Now, you're going to hit enter to perform the regression, and this screen looks perfectly the same. But if you go to y equals, all those numbers are now stored in your regression equation, which is
And
what
they're
we
not
want.
rounded off.
And they're not rounded off. Now, when you go to write the regression on your paper, you can go ahead and round to 3 places. So it's going to be, I have it here, f of c or y, f of c because it's fat per calorie. Okay, of 0.071x, rounded to the thousandths, minus 9.268. But in our calculator, we have all the decimals. And the reason we need that is for part B. How much fat is in a hamburger with 475 calories?
I don't know, but it probably tastes better.
It probably does. Stop talking about food. Okay, so what we're going to do...
It's like 7 o'clock in the morning.
It doesn't mean I don't want food. So
I don't
what
want
we're
a
going to do is
hamburger.
475 is our calorie number. So we're going to do the function of 475, correct?
Yep. So we're going to go bars, y bars.
Now notice Mr. Lecky
function,
started from his home screen.
y1. Oh, yeah.
He started from the home screen to get the y1, and then since we're doing function notation, put your parentheses, 475, boom.
And again, with the new one, you can just press alpha F4. You get to y1. It's quicker.
Okay, enter.
Yeah.
I don't have a new one. Get over it. Okay, so our answer is going to be 24.651.
This is how you should denote it.
Yes, please. 24.651. And these are grams because they are fat grams.
Yum.
Okay, so now, the other way we want to stretch you just a little bit on this problem is we want to talk about slope.
Keep it talking.
Okay, so in the context of this problem, what does the slope mean? So the slope was 0.071, but what does it mean?
Well, slope is a change in y over change in x.
It is.
In our problem, the y was fat in the grams, and the x is calories.
So is it change in fat over change in calories?
Yep. So it's the change in fat over the change in calories, which is really grams per calorie.
Ah, I gotcha.
And
So
since it's positive,
it's going up.
it's going up. So the fat is increasing
Okay,
0.071
grams.
per calorie. And you
Okay.
want that rate, that fractional G over cal thing.
Okay, so we're wanting you to get involved the units that you usually ignore.
Yeah, because in calculus, it's kind of
You need
important to have the right units too.
They're super
So
important.
it's important here now.
Okay, so we're not going to take any more video time with linear stuff. Let's talk quadratics.
Yay.
Find the vertex of this quadratic function. Well, we just got done doing transformations. So we should know that x plus 5 inside means we're going to go left 5.
Left 5.
And we should know that minus 2 means we're going to go down 2.
What's that 3 mean?
That 3 is a vertical stretch of 3. So if we're thinking of our transformations and we know that we're moving a parabola around, here's my parabola.
Well,
So our vertex is also going to move. It was at 0, 0. Now it's at left 5, down 2. So negative 5 and down 2. And there's our vertex. I always make him do the graphing. Okay, now if there's a vertical stretch by 3, instead of going over 1, up 1, over 2, up 4, okay, That's the parent function
That was
he's
the
drawing.
parent.
Okay. So instead of doing that, we're going to go over 1 up 3 times taller than that, so up 3. And 3 dots is really good enough for us. Over 2 would go up 12. You get the idea. It also asks for the vertex, so you would list that as well.
And that's a U-shaped graph in case it doesn't quite look that way.
It's a beautiful parabola.
It's really pretty.
Okay, next.
Was that too quick?
No, it's beautiful.
All right.
All right, so now some of us already know how to use this negative b over 2a thing, and where does that fit in? So we're going to show you where negative b over 2a comes from. If you've had Honors Algebra 2, you probably have already seen this, but in case you haven't.
Even if they did, they might not remember.
They might not. It was one little snippet. So let's see why this works.
All right, so we're trying to find the vertex, basically, of this equation. That's what our goal is, yes?
Right, that's a standard form equation.
And
No
in Algebra 1,
parentheses.
you were just told to memorize x equals negative b over 2a.
You were.
I'm going to throw a marker at the screen. and
Let me
then
get that.
We're going to go from there. All right.
Do you need me to write? Is that why? Is
I
that
got
a hint?
I got a finger. All right, we're gonna
Easy.
we're gonna expand that part of it.
Okay,
So-
so that's x minus h times x minus h. I put the marker
Put my
back.
marker
sorry.
down.
Okay, so that's going to be x squared minus 2xh plus h squared.
That's after a bunch of foiling.
Okay, so there's an a in front of that. So shouldn't we distribute an a?
So we have right now we have f of x equals a times this whole thing.
Yes, we do.
So that's going to be ax squared minus 2. Now I'm going to go ahead and write the a, then the h, then the x. Is that okay?
That's fine. Usually the x is the variable, so we put that last.
Plus ah squared,
And then there's a plus k.
and then don't forget the plus k.
Okay, so now what we want to do is we want to compare that function Mr. Lecky's written to ax squared plus bx plus c. So if we think about the x squared piece, they both have an a coefficient. So a is a, it's the same thing.
So the a in this problem, which is a vertical stretch.
Yes.
So the a over here
It's
is
the
also a
same
vertical
A.
stretch.
It does. And if it's negative, it shows you a flip.
Okay. So we can tell
All
if it
right.
opens up or down, how much it stretches just by that.
Yep.
I like
But
it.
let's look at the x term now.
X term. I have an x over here, so the x term is here.
Yes?
And over here I have this x term.
Okay. So now the coefficients must be equivalent because it's the same equation. All we did was multiply it out. So that means that negative 2ah has to equal b.
Ooh.
So now in this first equation right over here, the h was our horizontal shift. So let's solve this for the h, okay? Did I confuse you?
Yes, I was going to write shift, but I decided to write translation.
Translation's a better word.
How's that?
All right, so in negative 2ah equals b. Let's solve for h. So h equals,
How
divide
about-
by negative 2a.
b over negative 2a.
Oh, that's where it comes
And
from.
we just stick the negative out in front.
Okay. So that's where it comes from.
So our left motion or right motion of our parabola is negative b over 2a. It was not only the horizontal translation, it was the x value of our vertex, wasn't it?
It was. And it was also the line of symmetry.
It had a lot of stuff in there.
It's pretty important. That's why you memorized it in Algebra 1. Okay, fast forward. Let's see how this works.
All right. Fast
So
forward.
since we have this in standard form, we know the a, the b, and the c, and we're going to go ahead and find our vertex.
We start with the line of symmetry is x equals negative b over 2a.
So that would be the opposite of negative 6, so 6.
Positive 6.
Over 2 times 2, which is 4. So 6 over 4 is 3/2. Oh my goodness, a fraction. Okay, so the x part of our vertex is 3/2. I ask you, if you know x, how do you find y?
I'll plug it in.
Plug it in. So you're going to have
Plug
2
it in.
times, he's singing the song, 2 times 3/2 squared minus 6 times 3/2 plus 11. And then we do a whole bunch of fraction magic.
9/4, 5th grade hell. Here we go. This is going to be 3 times 3 is 9 plus 11.
Okay?
That's going to be 9
9
halves minus 9 plus 11.
Okay?
Let's just put it all over 2 just to make fractions more fun.
Let's do. So
That's
it's
9 minus 18 plus 22 halves. And that's,
So negative 9 plus 22.
is that 13?
It is.
Awesome.
So
What is
our-
that?
That's our y part of our vertex.
Ooh.
So our vertex is 3/2, comma 13/2.
Wow. So that's 1.5 and 6.5.
6.5. Mm-hmm.
2, 3, 4, 5, 6.5. So it's like right in the middle of this little box.
Sure is.
And from there, this a value is still our vertical stretch.
It is still our vertical stretch.
So
we
again,
could go,
instead of going from here to here for our first point, which was only one space away to the right and to up,
we're going to go over 1 and up 2. But we're going over one whole box, so we're still in the middle of a box now.
so we're
And up
going to
to.
end up here, yes?
Yes, we are.
And we're going to end up here?
We are. The other thing you could use is the fact that the 11, that constant, is your y-intercept. So our graph doesn't quite go up to 11, so that's why we're going over 1 and up 2. But you could do the same thing. We
Yay.
just need 3 dots. Okay.
That's like a smiley face.
That's because it's math, and it's happy. All right, so what are we going to do with these quadratic functions?
Make them.
In previous courses, you've done some modeling with them with projectile motion. We figure you already know how to do that. We'll cover that in class.
Modeling?
But Yeah, that's me. But there's some other applications. So let's go ahead and get into our last example here. All right, here we go. We have an apartment rental company, and it has 600 units. I'm sorry, 1,600 units available. 800 of them are already rented. Those zeros are
You're
kind of
making this
important.
apartment smaller by the minute.
And they're already rented for $300 a month. It's already a small apartment if it's $300 a month.
Sure, this is a long
Okay.
time ago.
So the market survey indicates that if you decrease the price, what will happen?
If the price goes down, you get more people.
You get more people. So we need a revenue, that's why that says R of X, a revenue model for the income, okay?
Revenue is the money you get in.
It's the money you get in.
Right
So
now, what are they getting?
they're getting $800 for, 800 apartments at $300 a piece.
So right now, they're just getting 800 times 300. Does that
Right.
make sense?
Right. So they're getting however many apartments are rented by however much they cost.
Okay.
So number of rentals times cost. I would write that down.
Okay.
Vanna.
Number of rentals
Times cost.
times cost
And that would be the cost of each one.
per rental.
Per rental. Okay, so let's look at these two things separately. If we look at the number of rentals, there are 800 currently rented, and they've already told us that X is the number of $5 decreases. So as the money goes down, the price goes down, more apartments are getting rented, and 20 more leases are getting rented for every $5 decrease.
So if I go down one $5 increase, I get 20 more people.
Yes,
If I do it twice, I get 20 more people twice.
correct. So all we got to do is take 20 times X.
So if I add 20,
Uh-huh.
every time I increase my rent or
Right.
decrease my rent,
Correct.
I get that many more rentals.
And so we're going to add that to the 800 rentals we already had.
Perfect.
Okay, so let's talk the money. So the
I like talking money.
yeah, the rentals were $300 to begin with, okay, and the money's decreasing by $5 per change. Did I say that right? $5 per X.
Every time we decrease $5,
Right.
we're taking $5 off of our cost. So we start at
Yes.
300. We
Then we
have
go
a
to
$5
$295.
increase. So X isn't really it's just the number of decreases.
Correct.
And each one of them is $5.
It's like the number of discounts.
Very good.
Okay,
So-
now the only other thing that's really important in this problem is it says determine a polynomial function. So that polynomial is technically factored. So this is where you want to read the directions. If you were to multiply all that out, I'll just help you out. It would be negative 100x squared.
You thought the fraction problem was bad. What was it?
Negative 100x squared. You're as bad as them. You don't even listen.
What?
Plus 2,000x. Plus 240,000.
I'm doing what you're doing.
Just dropping zeros. 240,000. 0, 0,
Those
0.
extra zeros are just placeholders, right?
Okay, so that's question A.
Do you know the Egyptians didn't have zeros?
Oh my goodness.
Okay,
I did
anyway.
not know that.
All right.
Thank you for sharing. So there's our function.
I could-
And I forgot to put it on
All
there.
right.
All right. So part B, we want a graph for this because obviously the apartment rental company wants the most money, right?
It says click here for a graph.
Are you ready to click?
I'm clicking.
Okay. I want to clarify that the reason this over here says that we're graphing from X is between 0 to 25. That's
So
okay.
we can't really decrease it too much or we lose all of our money.
Right. So if we look at this, it says find a graph. So we found a graph for you. You can type that in.
You'll have to play with your window to get it, but
You will.
there's a picture. Does it show a maximum?
It does. So what rental will yield the maximum? Oh, I have that.
Somewhere up here, right? So you
It's
go
10,
calculate max and
Yep. 250,000. So the question was, what rent? So how much does the apartment cost? Well, X is 10, but X is not money. X was
X
how
is
many
10.
decreases?
So we decreased
10 times.
$5,
At $5 a piece.
10 times.
That'd be $50.
All right. So our new rent
Is $250. Because it was 300.
is $250.
We knocked off 50 bucks.
So basically, it's saying that as I kind of give less and less money per month, I start gaining customers till I get to $250 a month. But after that, I'm renting it out at such a cheap price, I can't make as much money.
Correct.
Very good.
Alrighty. Linear and quadratic. That's it. Lesson 2-1.
That'll do it.
talking about the number of $5 decreases.
Right.